Welcome again. You are in the Emergent Media presentation, and for our grand finale, it's my pleasure to present Professor Kevin Klinger. Kevin received his MArch from the University of Illinois and his BA from DePaul University. Kevin is also the director of Ball State Institute for Digital Fabrication. Kevin's presentation is entitled Manufacturing Material Effects, Rethinking, Designing, and Making. Please join me in welcoming Kevin.
Can you guys hear me back there okay? Okay. I want to start off. What I'm going to show you is a presentation that I gave to the Architectural Record Innovation Conference just a couple of months ago. And I've tailored it a little bit because I really want to weave in a lot of the stuff that we've got going on here. So it's more of a customized presentation to showcase the work that we're doing. And then to really kind of promote this exhibition that just opened at Indianapolis Museum of Art, because I want you all to go down there and check it out. But honestly, I swear to you, I just got the final images of that project about 5 minutes ago. So that's how hot off the presses it is. So before I get started, I'm just going to talk a little bit about this notion of collaborative learning, working with digital fabrication. We're really aimed at trying to work with industry partners and get students working in that mix in very kind of innovative type situations. And to that effect, I want to just kind of give you this brief little video that we did last week. I'm just going to try and find a good spot.
Get into the picture.
So we can start plotting tomorrow.
All right, cool.
Yeah. So
hey, Lynn and Elizabeth, I'm getting ready to send you an email with the pictures that we took at Arrowhead. So you'll have all the stuff that we've been doing.
Great.
Here in a second.
Also, if you talk to Jamie Owings, he took a bunch of pictures while he was here yesterday. I know he's got a nicer camera than I do, so
okay.
I probably want to get some from
Why
him.
don't I try calling Jamie right now and see if he can, while you guys are talking, I'll try to get Jamie on the phone and connect with him about that.
All right, sounds good. Have him email him.
Yeah.
Or just stop by CMD or whatever.
Cool.
Good.
That'd be perfect, actually.
So how's the immersion learning going?
Oh, it's good. I'm making the structure right now for our new mold that'll get made tomorrow. So.
Excellent. And you've been consulting with Arrowhead Plastics on this?
Yep. Tom came in like a few times this morning to help us figure out how to make the mold. They're like, 'cause we have to basically, they'll spray in the fiberglass, and then I have to make the waffle structure that gets stuck into that. That way the fiberglass doesn't collapse like in the center planes.
Well, that's good. That's really great. They're stepping up and helping you guys. It's not enough to be connected. He's also texting. Say, can we see the progress you guys are making on the router? Triple tasking.
Yeah.
I'll go grab it.
Well, no, let's just bring that in there.
Yeah. This thing is so heavy.
Okay. Let me see. I'm gonna just briefly head back into that one. Just to move ahead a little bit. We're up in Eaton, Indiana right now. This is 10 miles north of here. We had our router that we purchased that is actually going to be here for the use of people at CAP is installed up in Eaton, Indiana right now temporarily just so that we could get operational and working with it. I'm going to show you a little bit of it. Nice shirt you have there. Hey, Rob. Hey, Rob. Ooh. So that's the router. Actually, that's the mold. It's crazy. This project is absolutely about this kind of multiple tasking. But I digress. The factory up in Eaton, the students have been working up there to actually put the thing together. They've been working with a company called Arrowhead Plastics. They've been helping them with mold making, working with plastics fabrication for the exhibition as well. And why that's important is because we feel that there's a responsibility to kind of serve what's going on in our region, to connect with industry, to connect with people that are doing things and making things here in Indiana. The case is that digital fabrication, as you saw in the presentation with the SOM work earlier, it's something that a lot of people around the world are really doing. And so what we're trying to do is frame that notion and then make the case that Indiana already has a strong tradition for making things. And so through connecting to this kind of global networks, we can also help Indiana industry enter into that conversation and make things better through working with these kinds of devices, techniques, etc. So to that end, we housed a symposium at the Indianapolis Museum of Art called Manufacturing Material Effects, where we invited a team of international designers, thinkers from around the world, people from the offices of Rem Koolhaas, OMA, Shop Architects, Jeannie Gang. There were about 19 speakers at that event gathered for the symposium. There's a book that's coming out. All of the chapters of that book have been edited over the past semester, and that book will be out in June. The book is also called Manufacturing Material Effects. And I'm going to show you some of the work of the architects and the fabricators that were present in that symposium. This is a firm called Barco Leibinger in Berlin. They're looking for interns right now, by the way. The studio basically is working in this campus called Trumpf. They're a CNC machine tool company. They're digitally fabricating and customizing these kind of daylight lighting systems for this cantina. They've been working on some office towers in Korea where they wanted to create a kind of facade system where, like in the 70s when everything got mirrored, the idea was that you'd have a perfect mirrored facade, but it never quite worked because the mirrors were always just slightly off, and so you always got this kind of ripple. Well, they said, well, let's celebrate the ripple and make it kind of consistently inconsistent. So this is the project under construction. This is some studies they had in their courtyard in Berlin of this kind of consistently inconsistent. They also have this machine tool that cuts these tube steels, and they're looking at developing these kind of lighting systems, as well as this really innovative facade system where these things can pivot on a point, and they can use it to control the daylight based on where things are located inside the building. So as the tubes spin, you can control the amount of infiltration of daylight. Then they also have this great piece, which is the gatehouse to the campus of Trumpf, where they wanted to achieve, like looking at Prouvé's gas station, where everything was built as a fabricated piece. They wanted to play on that, but they wanted to achieve this extreme cantilever. And you know the rules of cantilever. In cantilever, you have to keep 2/3 of it back and cantilever maybe a third out beyond the boundary. But they wanted to push that limit, and the way they were able to do that is looking at what was happening in the factory at the machine tool company, where they were fabricating these kind of like framing systems for panels. And then interrogating what that might be for architecture. They did some stress analysis tests in conjunction with an engineer, and they developed a system where the form of the piece is actually informed by the way that the stress moves through the piece, so they can achieve much greater cantilevers. And this is a way of kind of bringing this notion of the study, the simulation, the biological behavior of things into direct fabrication and being able to achieve those kinds of realities. You test it before you build it. You know exactly how it's going to perform and behave, and then you're able to achieve things that you may not have been able to just by cutting it out of cardboard. So some other examples of some firms that had some work. This is a little bit more Baroque in nature. This is the Federation Square in Melbourne, Australia, by Lab Architects. They were teaching at the AA. They won this competition. And then they moved down and did Fed Square, and they've been in Australia ever since. They're doing a lot of work now around in places like Dubai and other places. But essentially, they wanted to study this kind of panelization and how they could achieve opacity, transparency, translucency, openness in this kind of collage type facade skinning system. These are the actual construction documents. It was taken directly from the model. the information is so complex that it takes the algorithms to actually generate the form, but then they are able to take those algorithms and translate them directly into the model, which they can use to send directly to the fabricators and make every part and piece and component. And so these are some of the actual documents they use to get the thing built. This is coming directly from their model as well. Another one a little more locally is Studio Gang up in Chicago. This one just started construction. It's called the Aqua Tower, where they, instead of thinking of kind of like a surface effects that gets applied or wrapped around a building, they actually started to interrogate the floor slabs based on information on views and maximizing views along the lakefront there. And these are some of the renderings of the piece that's actually going up right now. And these are some of the diagrams they use to develop and study the facade system. I'm sorry, I'm going to go through these really quick because I really want to get to the student work. If you want to see this stuff in more detail, please stop by the Indianapolis Museum of Art for the exhibition, because a lot of this stuff is on display. There's a sensibility of materiality in a lot of these projects as well. Gina Gang also worked for the National Building Museum and developed this marble curtain, which is a kind of a hanging curtain, where they worked with Thornton Tomasetti, structural engineers, to figure out a way that they could use stone in tension, because stone is always in compression. And they wanted to figure out if there's some way that they could innovate looking at stone. And so they developed this kind of joint system, this kind of detailing here, where the whole thing is a kind of a puzzle piece, and it translates the loads all the way down to the ground, and all of the piece itself hangs from the ceiling. So it's actually stone acting as a curtain piece. Some other projects they have going in Chicago. And then, of course, Architecture Association, you all know Jason Johnson. He went there and has a good knowledge of this kind of working methodology. What's happening right now is this kind of morphogenetic design, evolutionary design, where they start with these kind of details, and through the parametric modeling let it ripple through the entire system. So you figure out a kind of a detail, and through variation and repetition, they're able to create these kind of innovative pieces that are very much about how the thing goes together at the elemental level. These are some of these studies things that they've done along the way. There's a huge group of them that are publishing quite widely right now. So beyond those kind of form pieces, the other aspect is people like shop architects we have an intern there right now working with these guys. They've gotten huge very quickly, and they're very interested in this notion of digital fabrication. For this Houston Street project in Manhattan, they developed a panelized system where they wanted to create variation along the facade. They discovered an old urban rule in Manhattan where you could vary the facade about 12 inches or something like that, and it had to do with ornament. How far could you stick the gargoyle out, into the sidewalk before it started encroaching on the city. And so they used that to actually develop a kind of innovative, unique facade system. The other rule is that they had to be working in brick. They were right next to this Puck building, this historic building in Manhattan. It's Soho. And so what they did is they brought the precast panel manufacturer into the office before they even began designing and said, what is it going to take? And they said, well, most of the money in precast is in making the mold, or making the kind of mold for the piece. And so what they ended up doing was they developed a liner inside of which gave them the variation. They used the same kind of precast panel, but then by varying the liner, they were able to create this kind of variation to create this kind of repetition. It was nearly the same cost it would take them for just doing a standard, typical flat facade. So this is a kind of an innovation that comes from working directly with industry at the very beginning. It's schematic design development. When you're trying to figure things out, you've got to have those kind of partnerships. As we heard earlier, those kind of blurring of the boundaries, that are really critical to engage in the process in ways that we haven't done in a long, long time, maybe since the separation of drawing and building. So again, some of the studies, these are the panel liners for the project, the parametric model stuff that they were working with. And then this gets to some of the interesting research about the kind of CNC technology as well. This is a group in Zurich at the ETH. They have a robot, which is it's a KUKA robot, where you can see it's actually carving these kind of panels based on these algorithms, where each panel can be unique and uniquely carved. And the robot has basically replaced the craftsperson. The craftsperson is now not the person who's carving and cutting and doing that sort of thing. It's somebody who's writing the code. The craft is happening at the level of software, at the level of code, understanding how the whole thing is kind of going together and that sort of thing. Other interest, you're able to create these kind of dynamic and phenomenal effects with these panels. So as you walk along, the wall, this light kind of effect follows you as you move along, depending on where your point of view is, making the facade a much more dynamic thing. They're also interrogating additive process, where they program the robot to build brick walls, which is really unbelievable and pretty amazing. But they're able to achieve these really kind of interesting effects. You even program the robot to lay the glue to adhere the brick wall on the piece itself. So here's a panelized system. They've applied this to a winery in Flash, Switzerland, where they have this kind of basket of grapes inside the kind of image here, and then they're able to use the robot to fabricate these unique wall panels, and then creating amazing effects by dematerializing brick on the inside of that system. So these are some of the other kinds of studies of things that they're doing at the ETH. We're also seeing other firms that situate themselves between people like Zaha Hadid and the fabricators, and I'm going to fly through this because I just saw my time card and I want to get to the student work, as well as Daniel Libeskind and some of the work that he's been doing. We're seeing these innovative groups that are developing to actually help translate something from bits to atoms. And that's kind of an innovation that we're seeing in architecture as well as fabricators that are becoming much more architectural design savvy and investing in this kind of high-tech equipment and positioning themselves as the go-to place to achieve these kinds of projects. People like Zahner Architects in Kansas City, as well as Freeform, working with a number of people. So this is the content of MMFX. These are the people who were invited to the table and will be featured in the book project. Essentially, with the digital fabrication, it's about the CNC technology. It's about these kinds of laser cutter machines like we have here. It's about these CAM labs that we see at places like Delft, as well as ETH and Zurich, as well as Ball State University. Figuring out tolerances and new ways of understanding the information, devices that we use to cut things, to produce things, industry partnerships like we have with the limestone industry and the hardwood industry and others, as well as modeling information and scripting, which becomes very, very important. Okay, so onward to what we've done recently with the Institute for Digital Fabrication. There's one project that we worked with the limestone and hardwood people and developed this bench called the calibration channel at Mound State Park, where the actual sound of the river kind of travels up the hill and the bench captures it and amplifies it, and it really works. When you sit on the bench, you actually get this sweet spot, and you can hear the river much louder than you would if you were just sitting in the open space. And this was a student-driven project. Another project where we worked with Shop Architects and Zahner Metals to develop this parametric boundary system, as well as an installation in Indianapolis Art Museum. And finally, this is what I've been flashing through very quickly to get to. This is what we've been doing recently at the Indianapolis Museum of Art, collaborating with a team of fourth and fifth year architecture students to develop an exhibition piece on the router that we've installed up at Eaton, as well as with industry partners in the plastics industry. This is the mold they're using to actually form the acrylic panels. This is where they were when they were having that video chat. These are some of the acrylic panels that they've developed. And this is up in the Digital Fab Lab up in the Series side of the building, where the students are doing some studies about the light intention and the effects of the exhibition. These are very rudimentary, kinds of studies of how they want the piece to be. They developed every single joint and detail and sent it out for fabrication with Midwest Metals, and so there's nothing that's been developed or purchased from. Well, there's a couple things that have been purchased from Lowe's, but the idea is that everything is detailed and fabricated in-house. They've been working with the veneer industry, who just donated $3,000 worth of Indiana hardwood veneer to us. They've been working with the plastics company up in Eaton, as well as Muncie. The Indiana limestone industry as well, to develop kind of foot system for the display. And then here is the student working up in the factory in Eaton, pulling the thing together, navigating the relationship between bits and atoms, making these things translatable. Here they are inside of the space, working with the plastic, forming the piece. There is our CNC operator extraordinaire, who has learned every aspect of how to operate the CNC equipment and knows the thing intimately. Great. We're very grateful to Rob and his energy on that. The students developed this kind of encoding system so that there's a code on every single panel piece. They can read the board, and it tells them exactly where it goes in space. And here it is, finally installing at the Indianapolis Museum of Art. This was last week. They also developed this kind of joint system where the boards will slip together, and all of that stuff was CNC manufactured by them. Here they are spreading out the panels, and the boards are starting to go up. You can see the kind of plastic acrylic pieces. There's a light that goes behind these. We have models from all of the people in the exhibition, as well as this kind of framing system. They're melting the plastic to fit it into place, setting the piece up, and working a lot with their hands right now to get this thing done. And of course, this is some of the content in the exhibition, like places like Arrowhead, who are working with us on the router, but they've developed a magazine rack for Kareem Rashid in Manhattan and on Madison Avenue. But all of them were made here in Muncie, and so we want to showcase that in the exhibit and say Indiana is a place where things get made. And so, again, the Gene Gang's Tower is part of the exhibition as well. There's also a multimedia kind of piece in the back that's part of the Institute for Digital Intermedia Arts. And the limestone folks gave us a gargoyle, which I think is actually quite fitting, because this piece, as people have been talking about the digital, is this kind of neo-Baroque. I don't believe that at all, by the way. It's not this kind of hyper-ornamentation. It's much more about how things get made now. And to me, that's almost a kind of a Gothic mentality, that you master the material, that you understand how things go together, and that sort of thing. So I'm going to leave you with this image. This is the one that I just got. This is as of 10 o'clock last night. The final piece is up, and the students are enjoying the content of the exhibit and taking a breath from all of their good work. I think it's actually quite appropriate that we have this gargoyle standing as a sentry to the piece, and these things are like flying buttresses, as they are inverted flying buttresses inside of that space. So the buttress and the gargoyle have a nice kind of relationship with one another again. So that's it, and this is the institute that has helped sponsor all of this in partnership with the College of Architecture and Planning, as well as a lot of the industry partners. But most importantly, it's about the students. Right, Wes? All right. Thank you.
We have time for a couple of questions.
Yeah, the question was, are there fabrication places in Indiana that are using this kind of equipment? Yes, there are. Like we're finding there's a sort of a different level in the different industries. We've taken this kind of material-based approach, so we're working with metals, plastics, wood, limestone, and like metal, for instance, is fairly tooled up. It's pretty easy to find fabricators to make things in metal. With limestone, they're not tooled up at all. There's a couple of people that have some CNC technology. There's one here in Indiana that actually did all of the limestone here on McKinley Avenue. That they have a 5-axis CNC machine. They only use it in 3-axis. They don't have any time for research and development. They're basically just, they just finished the New York Yankees Stadium. And so those kinds of things, give them an opportunity to maybe try one innovation, but they're not doing much research and development. And a lot of the limestone folks are monetizing the limestone by developing stair tread replacements, where they take the stone and they slice it into like bread slices, and then they use it to actually, just replace worn stair treads. So they're not really invested in the research or the high-tech equipment, but there's such a potential for them to be doing that sort of thing. But other industries are much more advanced. The plastics people have been working in rapid prototyping for years. This is nothing new to them. So it's not like we probably are learning more from them, quite frankly, than we have to bring to the table. So there's a different depending on what industry you're talking about.
Sorry, I was just stretching my hand, but since I got my microphone, maybe I can figure out the question. I was very impressed by the images about the robots, and do you see the type of working processes replacing normal manufacturing in our conventional building sites?
Yeah, it's interesting. I mean, in fact, like CNC technology has been around for a long time, and they've been using it in the automobile industry for such a long time already. So we're really late in the conversation, really late in the game about deploying these things in buildings, but it is starting to happen now. Maybe you roll a robot out to the site and it builds the building for you, those kinds of things. Sure, I could see stuff like that happening. I think, one of the things that, even with the student work, though, that they've discovered is that they still have to do stuff by hand. There's nothing, the tolerances may be off a little bit. You have to have people who have the expertise in how things go together still being fundamental and part of that. A lot of the manufacturing stuff is about, I think, building it in a controlled environment inside of a factory, and then, through prefabricated panels, sending it onto the site and then having it erected. So maybe it's, I don't know, maybe we think of assemblers in a different way of how they put things together, and the thing comes together with like a set of instructions of how you put something together, like you would get if you had, a piece of furniture from IKEA or a model or those kinds of things.
Well, I think we can continue actually the discussion over lunch, but I just want to say, it really makes me feel proud to be part of Ball State. I think, as Craig said, we have just fantastic faculty here. They're doing wonderful things, as you can see, and I want to thank our panelists for sharing with us. And again, thank you to all. Please join us for the lunch period, and then we'll continue some more sessions a little bit later. Thanks.